Comprehensive Study Guide, Column Quality, Column Distribution, and Column Profile Features in Power BI 1. Introduction to Column Quality, Distribution, and Profile Features Overview. Power BI's column quality, column distribution, and column profile features found in Power Query provide essential insights into your data. These features enable you to analyze data completeness, detect patterns or anomalies, and ensure data accuracy, making them essential for data profiling and cleaning. Key benefits: data quality assessment. Detect null, error, or empty values. Understanding data distribution. Identify how data is distributed across different categories or ranges. Data profiling. Provide summary statistics, for example, counts, minimum, maximum, for numerical and text columns. 2. Accessing these features in Power Query to use column quality, column distribution, and column profile, you must be in Power Query Editor. Steps. 1. Open Power Query Editor. In Power BI Desktop, go to the Home tab. Click Transform Data to open the Power Query Editor. 2. Enable data profiling features. In Power Query Editor, go to the View tab. Enable the checkboxes for Column Quality, Column Distribution, Column Profile 3. Column Quality Definition. Column quality is a feature that provides a visual indicator of the data quality within each column. It shows the percentage of valid, error, and empty, null values for each column. How it works: valid values, the percentage of non-null, error-free values. Error values, the percentage of values that contain errors, for example, incorrect data types. Empty, null values, the percentage of values that are null or empty. Visual indicators. A colored bar above each column shows green for valid, red for errors, and yellow for empty values. Use case example. If a column is supposed to contain date values but shows 10% errors, you can use column quality to quickly identify and resolve those problematic entries. 4. Column distribution definition. Column distribution helps visualize the distribution of unique values within a column. It provides a bar chart of the distinct values, making it easier to spot data patterns, anomalies, and outliers. How it works: displays a visual histogram for categorical or text columns. Shows the distribution and frequency of distinct values for better understanding of data diversity. Visual indicators. A histogram-like visualization is presented, where taller bars represent more frequent values. Shorter bars represent less common values. Use case example. For a column containing country names, column distribution allows you to see if there's a heavy skew towards one country, or if all countries are fairly represented. 5. Column profile definition. Column profile provides a comprehensive statistical summary for each column, offering detailed insights into the column's data. Key metrics displayed: count of distinct values and count of unique values. Minimum and maximum values for numeric and date columns. Average, median, standard deviation for numeric columns. Frequent values and their counts. Null value count. How it works: column profile offers a detailed statistical breakdown and helps in understanding the range, central tendencies, and anomalies in your data. It also shows a value distribution chart, providing a deeper view into the frequency and range of the column's values. Use case example. For a sales amount column, you can use column profile to see the minimum, maximum, and average sales values, ensuring that the data aligns with your expectations. 6. Use cases for these features. Data validation. Use column quality to verify the integrity of imported data and quickly identify problematic areas. Outlier detection. Column distribution and column profile help you identify outliers or unexpected patterns in your data. Data cleaning. Detect empty, null, or erroneous data and take corrective action using Power Query's transformation tools. Data understanding. gain a better understanding of how data is spread across categories, helping to ensure accurate reporting and analysis. 7. Best practices for using column quality, distribution, and profile. 7.1 Use early in data preparation. Use these features right after importing your data to identify data quality issues before you start building reports or dashboards. 7.2 Combine with data transformations. After identifying issues using column quality or distribution, apply Power Query transformations. For example, fill nulls, replace errors, to clean the data. 7.3 Focus on key columns first. Prioritize important columns, for example, date, customer, sales amount, to ensure that critical data is clean and accurate. 7.4 Use with large datasets. Enable column profile for smaller samples if working with large datasets, as profiling entire large datasets can be resource intensive. 8. How to use these features for data cleaning. 1. Check for errors. Use column quality to detect any errors. For example, if a column meant to store numbers contains text, the column quality indicator will flag this. Use Power Queries replace errors or remove errors functions to clean the data. 2. Identify missing values. Column quality shows the percentage of nulls. Use the fill down or replace values transformations to handle missing data. 3. Detect duplicates. With column profile, you can see the number of distinct and unique values in a column. This is helpful for identifying potential duplicates, which can be removed using the Remove Duplicates feature. 4. Check data distribution. Use column distribution to visualize whether your data is spread evenly or if certain values dominate. This can help identify if further cleaning or transformation is needed. 9. Performance impacts and considerations. Performance impacts. Enabling column quality, distribution, and profile for large datasets can consume significant resources. Power BI may slow down when these features are enabled, especially for datasets with millions of rows. Best practices to mitigate performance issues. Use column profiling on a sample. Instead of profiling the entire dataset, Power BI provides the option to profile based on a smaller sample, improving performance while still offering valuable insights. Disable when not in use. Once you've performed your data profiling, disable these features to maintain optimal performance. 10. Advanced tips and tricks. 10.1 Column profiling for specific columns. You can enable column profile for specific columns rather than for the entire dataset. Right-click the column and choose Column Profile from the context menu. 10.2 Combining with M-code. If you prefer more control, you can use M-code in Power Query to apply transformations based on the insights provided by column quality, distribution, or profile. 10.3 Using custom functions. If you frequently need to clean similar types of data, for example, handling nulls or errors, create custom functions in Power Query and apply them across multiple columns. 10.4 Leverage Power Query diagnostics. After using column quality, distribution, or profile, you can use query diagnostics in Power Query to check the performance impacts of your transformations. Comprehensive Study Guide. Data Modeling in Power BI 1. Introduction to Data Modeling in Power BI. What is data modeling? Data modeling in Power BI refers to the process of designing how your data is connected and organized. A strong data model makes it easier to build reports, ensures high performance, and supports advanced calculations and analysis. Key benefits: ensures accurate reporting by creating proper relationships between datasets, reduces complexity in building reports by normalizing and organizing data, improves performance by optimizing data structures and relationships, enables advanced analysis through calculated columns, measures, and relationships. 2. Core concepts of data modeling. 2.1 Tables. Definition. Tables are the core building blocks in Power BI's data model. They contain rows, records, and columns, attributes, derived from data sources like Excel, databases, or cloud services. Role in data model. Tables are the foundation, and understanding their structure is critical to efficient modeling. In Power BI, you can import, clean, and shape tables using Power Query before incorporating them into your model. 2.2 Relationships. Definition. Relationships are the connections between tables that allow Power BI to generate insights based on data from different tables. Types of relationships. One-to-one. 1, 1. Each record in table A relates to one record in table B. One-to-many. 1, n. A single record in table A can relate to many records in table B. Many-to-many, nn. Multiple records in table A relate to multiple records in table B. 2.3 Keys. Primary key. A unique identifier for records in a table. Foreign key. A column in one table that references a primary key in another table, creating a relationship between the two. 2.4 Schemas. Star schema. A design where a central fact table connects to multiple dimension tables. Recommended for Power BI. Snowflake schema. A more complex design with dimensions further normalized into additional tables. 3. Types of data models. Power BI supports several types of data models. Single table model. All data is contained in one table, suitable for simple datasets, but limited in scalability. Relational model. Uses multiple tables connected via relationships. Ideal for more complex data with multiple dimensions. Star schema model. A central fact table with direct connections to dimension tables. Recommended for performance. Snowflake schema model. A more normalized model where dimension tables are further broken into subtables. 4. Data model optimization. Goals of optimization. Improve performance by reducing query times and memory usage. Ensure accuracy by establishing correct relationships and cardinality. Support scalability as the dataset grows and becomes more complex. Best practices for optimizing data models. Use fact and dimension tables to organize data logically. Minimize the number of calculated columns and prefer measures. Ensure single-direction relationships unless bidirectional is necessary. Remove unnecessary columns and tables to keep the model lean. Group data tables logically to improve clarity and organization. 5. Common data modeling scenarios in Power BI. Scenario 1. Sales dashboard, fact table, sales transactions, storing order details. Dimension tables, date, customer, product, and region. Relationships. Sales transactions relate to dimension tables via foreign keys, for example, customer-id, product-id. Scenario 2. Financial reporting, fact table, general ledger entries, storing financial transactions, dimension tables, date, account, department, and project. Relationships, ledger entries linked to the account and other dimension tables. 6. Understanding relationships and cardinality. Cardinality defines how records in one table relate to records in another. One-to-one, 1, 1. A rare relationship where each record in one table relates to exactly one record in another. One-to-many, 1, n. Common in Power BI, where one record, for example, customer, relates to many records, for example, sales orders. Many-to-many, nn. Less common and should be used with care to avoid performance issues. Cross-filtering. Power BI supports single direction or bidirectional cross-filtering. Use single direction for most cases, as bidirectional filtering can cause performance issues and ambiguity. 7. Managing data with Power Query. Power Query overview. Power Query is the data preparation tool in Power BI, allowing you to extract, transform, and load ETL data before modeling. Key functions in Power Query. Remove unnecessary data. Filter out unneeded rows or columns to keep your data model efficient. Data transformation. Transform raw data into a usable format. For example, unpivoting columns, creating calculated columns. Merge and append. Combine data from different sources into a unified table for analysis. Data load settings. Load to data model. Ensure only relevant tables are loaded into the model. You can disable loading for intermediate or helper queries. 8. Star schema versus snowflake schema. 8.1 Star schema. Definition: a simplified relational model with a single fact table at the center and dimension tables directly connected. Benefits: fast query performance, easier to understand and maintain, ideal for reporting tools like Power BI. 8.2 Snowflake schema. Definition: a more normalized structure where dimension tables are further subdivided into additional tables. Benefits: reduces data redundancy, suitable for complex databases but less optimal for Power BI. Best practice: use a star schema for most Power BI models to improve performance and reduce complexity. 9. Performance optimization tips for data models. 9.1 Avoid bidirectional relationships. Use single-direction relationships for most scenarios. Bidirectional relationships should only be used when necessary and with caution due to potential performance impacts. 9.2 Use fact and dimension tables. Centralize your numerical data, for example, sales, costs, in a fact table, and separate descriptive data, for example, customers, products, into dimension tables. This improves clarity and performance. 9.3 Minimize calculated columns. Calculated columns are stored in memory, increasing model size. Use DAX measures instead, which are calculated at query time and don't consume memory. 9.4 Optimize data types. Use the most efficient data types, for example, integer instead of text, to reduce memory usage and improve query performance. 9.5 Use summary and aggregation tables. Pre-aggregate data at different levels, for example, monthly totals, and use these summarized tables in your reports for faster calculations. 10. Advanced modeling techniques. 10.1 Role-playing dimensions. Definition: when a single dimension table, for example, date, needs to relate to multiple columns in a fact table, for example, order date, ship date. Solution: duplicate the dimension table and create separate relationships, for example, order date and ship date, or use calculated tables. 10.2 Calculation groups. Definition: calculation groups allow you to define common calculations, for example, YTD, QTD, once and apply them to multiple measures. Benefits: simplifies the model and reduces the number of explicit measures. 10.3 Aggregation tables. Definition: aggregation tables store pre-aggregated data at different granularity levels, for example, daily, monthly totals, to speed up queries. When to use: when you have a large dataset and need to improve query performance. Comprehensive Study Guide. Power BI Bookmarks 1. Introduction to Power BI Bookmarks. What are bookmarks? Power BI bookmarks allow you to capture the current state of a report page, including filters, slicers, and visual properties, and save it for later use. These bookmarks can then be used to navigate to specific views of the report, creating an interactive experience for users. Key benefits: allows users to save report views for quick access, enables dynamic navigation without needing multiple report pages, enhances storytelling and presentation within reports, simplifies user experience by creating a tailored navigation experience. 2. Accessing and creating bookmarks. Steps to create a bookmark. 1. Open Power BI Desktop or Power BI Service. 2. Navigate to the View tab. Ensure the Bookmarks pane is enabled. 3. Set up your report view. Adjust filters, slicers, and visuals to the state you want to save. 4. Create bookmark. Go to the Bookmarks pane. Click Add to create a new bookmark based on the current view. 5. Rename bookmark. Optional. Right-click the bookmark and select Rename to give it a descriptive name. Editing bookmarks. To update a bookmark, modify the report state and right-click the bookmark, then choose Update. Deleting a bookmark is done by right-clicking the bookmark and selecting Delete. 3. Types of bookmarks. Power BI supports two main types of bookmarks, each serving different purposes. 3.1 Default bookmarks. These bookmarks capture the current state of the report page, including filters and slicers, visual interactions, for example, highlighting and drill down, visual properties such as visibility, position, and sorting, current page location, 3.2 personal bookmarks, available in the Power By service, web version. Personal bookmarks allow individual users to save their personalized views of a report without affecting the report design. Personal bookmarks are only visible to the user who creates them and can be set as the default view when opening the report. 4. Key bookmark features 4.1 capturing visual and filter states. Bookmarks allow you to save the state of slicers and filters. Capture current selections for future use. Visual interaction. Preserve cross-filtering and cross-highlighting behavior. Drill through and drill down. Save specific levels of drill down or drill through actions. 4.2 display options for bookmarks. When setting up bookmarks, you can choose what aspects of the report to capture. Data. Captures filter, slicer, and drill through states. Display. Captures the visibility, position, and state of visuals. Useful for hiding/showing content. Current page. Saves the currently selected page in the report. 5. Use cases for bookmarks. 5.1 Simplified navigation. Use bookmarks to allow users to navigate between different parts of a report without creating multiple pages. Bookmarks combined with buttons can make navigation more intuitive. 5.2 Storytelling and presentations. Create a sequence of bookmarks to tell a story or create a guided walkthrough of the report. Bookmarks can switch between different views of the same data, highlighting trends or insights. 5.3 Dynamic report states. Switch between different report configurations. For example, different filter settings, slicer states, or visual arrangements, to allow users to view data from multiple perspectives with one click. 5.4 Toggle visuals. Bookmarks can be used to show or hide visuals based on user interaction, creating a dynamic report interface. For example, toggling between a chart and a table view based on a bookmark. 6. Advanced bookmarking techniques. 6.1 Using bookmarks for dynamic visibility. You can create bookmarks that control the visibility of visuals. For instance, create two bookmarks, one with a visual visible and one with it hidden. Assign these bookmarks to buttons so users can toggle the visual on and official. 6.2 Combining bookmarks with selections pane. The selections pane helps manage which visuals are shown or hidden for each bookmark. You can organize visuals into layers, show/hide specific visuals based on the current bookmark, control the layout of report elements dynamically. 6.3 Grouping bookmarks. You can group bookmarks together to create logical sets of interactions. For example, in a multi-step analysis, group related bookmarks so that they are easily identifiable and manageable. 7. Best practices for using bookmarks. 7.1 Descriptive bookmark names. Give bookmarks descriptive names based on their function. For example, North America View, Detailed Sales Breakdown. This makes managing multiple bookmarks easier. 7.2 Limit bookmark complexity. Avoid creating too many bookmarks that capture every visual state. Keep them simple and targeted to the essential aspects of the report. 7.3 Use bookmarks with buttons. Pair bookmarks with buttons to create a user-friendly, clickable experience for navigating through a report. Users can click on buttons to switch between views instead of using the bookmarks pane. 7.4 Use for presentations. If you're using Power BI for live presentations, bookmarks help you jump between key report views and avoid having to reset filters manually. 8. Practical examples. Example 1. Navigation between report sections. Create bookmarks that switch between different sections of a report. For example, Overview, Detailed Analysis, Key Performance Indicators. Pair with buttons for intuitive user navigation. Example 2. Toggling between views. Set up a bookmark to switch between a chart view and a table view. Use buttons labeled Chart View and Table View to switch between these bookmarks dynamically. Example 3. Storytelling. In a report presenting quarterly performance, Create a series of bookmarks that highlight different course data and trends. Use the Bookmarks pane to create a narrative, guiding users step by step through the story. 9. Bookmark navigation and buttons using buttons with bookmarks. Buttons. Add buttons from the Insert tab. These can be linked to bookmarks to create interactive navigation. Assigning bookmarks. Select the button, then in the Format pane, under Action, choose Bookmark and select the desired bookmark. Adding bookmark navigation. Buttons or shapes can be used to create a dynamic navigation experience, such as moving between different parts of a report or toggling data views. 10. Advanced Tips and Tricks 10.1 Bookmark Navigator Visual. Power BI offers a Bookmark Navigator visual that can automatically create a clickable menu based on the bookmarks in the report. This is great for switching between different views or report states. 10.2 Hidden Elements with Bookmarks. You can create more interactive reports by hiding elements using bookmarks. For example, you can show a detailed chart only when the user clicks a View Details button. 10.3 Drill-Through with Bookmarks. Combine drill-through functionality with bookmarks to create more interactive and dynamic report navigation. This provides the user with a deep dive into specific data points without losing context. By mastering Power BI bookmarks through this study guide, you'll be able to design reports that offer a dynamic, interactive, and user-friendly experience. These bookmarks will improve navigation, storytelling, comprehensive study guide. Power BI Performance Analyzer 1. Introduction to Performance Analyzer Purpose. Performance Analyzer is a built-in tool in Power BI Desktop designed to help developers monitor and analyze the performance of their reports. It provides detailed insights into how long each component of a report takes to execute, enabling targeted optimizations. Key benefits: identifies slow-performing visuals, helps optimize DAX queries, assists in improving overall report responsiveness, facilitates better user experience by reducing load times. 2. Accessing and setting up Performance Analyzer steps to access. 1. Open Power BI Desktop. 2. Navigate to the View tab on the ribbon. 3. Click on Performance Analyzer to open the Performance Analyzer pane. Initial setup. Start recording. Click the Start Recording button to begin capturing performance data. Interact with the report. Perform actions like filtering, drilling down, or refreshing visuals to generate performance metrics. Stop recording. Click Stop Recording once interactions are complete to review the captured data. Settings. Include DAX queries. Ensure that DAX queries are included for detailed analysis. Export options. Configure export settings if you plan to analyze data externally. 3. Understanding the Performance Analyzer interface. The Performance Analyzer pane consists of several key components. Start recording. Initiates the logging of performance data. Stop recording. Ends the current logging session. Refresh. Refreshes all visuals on the current page and logs their performance. Clear. Clears all previously recorded performance data. Export. Saves the recorded data as a JSON file for external analysis. Details pane. Displays individual metrics for each visual, including DAX query time, visual display time, and other processes. Visual list. Each visual on the report page is listed with expandable details showing DAX query, time taken to execute the underlying DAX query. Visual display, time taken to render the visual. Other, time attributed to miscellaneous processes. 4. Key metrics in depth. Understanding the core metrics provided by Performance Analyzer is crucial for effective optimization. 4.1 DAX query, time. Definition: time taken to execute the DAX query that retrieves data for a visual. Components: query execution, the actual running of the DAX formula. Data retrieval, fetching data from the data model. Implications: high time may indicate complex or inefficient DAX formulas, large data volumes, or suboptimal data models. Low time suggests efficient queries and well-structured data models. 4.2 Visual display time. Definition: time taken to render the visual after data retrieval. Components: rendering, drawing the visual on the screen. Formatting, applying styles, colors, and other formatting options. Implications: high time could be due to complex visuals, excessive data points, or heavy formatting. Low time indicates simple and efficient visual designs. 4.3 Other time. Definition: time consumed by processes not directly related to DAX execution or visual rendering. Components: background processes, internal power by operations. Network latency, especially relevant for direct query models. Implications: high time may point to network issues, large data model sizes, or other system-level constraints. Low time indicates minimal overhead from external factors. 5. Analyzing performance data step-by-step analysis. 1. Start recording. Click Start Recording to begin capturing data. 2. Interact with report. Engage with the report by filtering, slicing, or navigating between pages. 3. Stop recording. Click Stop Recording to end the session. 4. Review metrics. Examine each visual's DAX query, visual display, and other times. 5. Identify bottlenecks. Look for visuals with disproportionately high times in any category. 6. Drill down. Expand individual visuals to see detailed metrics and DAX queries. Visualization. Sorting. Sort visuals based on any metric to quickly identify top performers or laggards. Filtering. Focus on specific visuals or types of visuals to streamline analysis. 6. Common performance bottlenecks and solutions. 6.1 Complex DAX expressions issue. Inefficient DAX formulas can significantly slow down query execution. Solution: simplify DAX expressions. Use variables, VAR, to store intermediate results. Avoid nested or excessive functions. 6.2 Large data volumes issue. Handling vast amounts of data can slow down both queries and rendering. Solution: implement data reduction techniques like aggregations. Use incremental data loading. Optimize data types and remove unnecessary columns. 6.3 Inefficient data models issue. Poorly structured data models with complex relationships can hinder performance. Solution: adopt a star schema design. Minimize the use of bidirectional relationships. Optimize relationships by using single direction where possible. 6.4 Visual complexity issue. Highly detailed or interactive visuals can increase rendering time. Solution: limit the number of data points displayed. Choose simpler visual types. Reduce the use of conditional formatting and custom visuals. 6.5 External factors issue. Network latency or slow data sources can impact performance, especially in direct query mode. Solution: optimize network infrastructure. Use import mode where feasible. Ensure data sources are performant and indexed appropriately. 7. Optimization techniques. Optimizing Power BI reports involves addressing issues at various levels: DAX queries, data models, and visuals. 7.1 Optimizing DAX queries. Use variables, VAR. Store intermediate calculations to avoid redundant computations. Avoid unnecessary calculations. Remove or simplify calculated columns/measures that aren't essential. Leverage aggregations. Use aggregation tables to pre-calculate summaries and reduce on-the-fly computations. Minimize the use of calculate. Use simpler functions or context modifiers when possible. Filter early. Apply filters as early as possible in your DAX expressions to reduce data volume. Example: inefficient DAX. DAX total sales equal calculate sums a less amount. Filter sales, sales region equal north. Optimized DAX. DAX total sales north equals sum x filter sales, sales region equal north. Sales amount. 7 point. 2. Optimizing data models. Adopt star schema. Organize data into fact and dimension tables for clarity and performance. Reduce table size. Remove unused columns and tables. Optimize relationships. Use single-direction relationships where possible. Ensure relationships are based on unique keys to enhance performance. Use appropriate data types. Choose the most efficient data types. For example, integers instead of strings for keys. Hide unused columns. Prevent clutter and reduce processing by hiding columns not used in reports. 7.3. Optimizing visuals. Limit data points. Display only necessary data to prevent overload. Choose efficient visual types. Prefer simple visuals like bar charts over complex ones like scatter or map visuals when possible. Simplify formatting. Reduce the use of conditional formatting and intricate styles that can slow rendering. Disable unnecessary interactions. Turn off features like cross-highlighting or tooltips if not needed. Use aggregated data. Display summarized data instead of detailed granular data where appropriate. 8. Advanced tools and integration enhancing performance analyzers' capabilities can provide deeper insights and more robust optimization opportunities. 8.1. Using DAX Studio purpose. DAX Studio is a powerful external tool that allows for advanced DAX query analysis and optimization. Integration steps. 1. Install DAX Studio. Download and install from the official website https://daxstudio.org/. 2. Connect to Power BI. Open DAX Studio and connect it to your active Power BI desktop instance. 3. Copy queries. Use Performance Analyzer to copy DAX queries and paste them into DAX Studio. 4. Analyze queries. Examine query plans, server timings, and optimize accordingly. Benefits. Detailed query analysis. Ability to test and refine DAX expressions. Performance benchmarking against different queries. 8.2. Using SQL Server Profiler purpose. SQL Server Profiler captures and analyzes SQL queries sent to the underlying database, especially useful for direct query models. Integration steps. 1. Open SQL Server Profiler. Launch the tool from SQL Server Management Studio, SSMS. 2. Set up a trace. Configure a new trace to monitor queries from Power BI. 3. Run the trace. Execute interactions in Power BI and observe the captured SQL queries. 4. Analyze queries. Identify slow or inefficient SQL queries and optimize the underlying database. Benefits. Insight into data source performance. Identification of slow-running SQL queries. Optimization of database indexes and structures based on observed queries. 9. Practical case studies. Case study 1. Optimizing a slow sales report scenario. A sales report with multiple visuals is experiencing long load times. Performance Analyzer shows high DAX query and visual display times for several charts. Steps taken. 1. Identify bottlenecks. High DAX query times in the sales trend chart. High visual display times in the geographic map. 2. Optimize DAX queries. Simplified the DAX formula for calculating total sales. Implemented variables to store intermediate results. 3. Optimize visuals. Change the geographic map to a simpler bar chart. Reduce the number of data points displayed by applying filters. 4. Review performance. DAX query times reduced by 40%. Visual display times reduced by 50%. Overall report load time decreased from 8 seconds to 3 seconds. Outcome: significant improvement in report responsiveness, enhancing user experience. Case study 2. Enhancing a financial dashboard with direct query scenario. A financial dashboard using direct query mode is slow due to high network latency and inefficient SQL queries. Steps taken. 1. Analyze with SQL Server Profiler. Captured SQL queries and identified slow-running queries. Noted missing indexes on key tables. 2. Optimized database. Added necessary indexes to improve query performance. Revised SQL queries to be more efficient. 3. Adjust Power BI settings. Switched from direct query to import mode for less frequently updated data. Implemented aggregations to reduce query complexity. 4. Review performance. SQL query execution times decreased by 60%. Dashboard load times improved from 12 seconds to 4 seconds. Outcome: enhanced dashboard performance, enabling real-time financial analysis with reduced latency. 10. Best practices and tips. Regular monitoring. Continuously use Performance Analyzer during report development to catch performance issues early. Modular development. Develop and test visuals individually to isolate performance impacts. Efficient data modeling. Prioritize a well-structured data model using best practices like star schemas. Optimize incrementally. Tackle one performance issue at a time to avoid overwhelming changes. Leverage aggregations. Use aggregated tables to minimize real-time data processing needs. Stay updated. Keep Power BI Desktop updated to benefit from performance improvements and new features. Collaborate and share insights. Share Performance Analyzer exports with team members for collective optimization efforts. By following this comprehensive study guide, you'll gain a thorough understanding of Power BI's Performance Analyzer, enabling you to diagnose performance issues effectively and implement optimizations that enhance the responsiveness and efficiency of your Power BI reports. Continuous practice and leveraging the available resources will further solidify your expertise in optimizing Power BI performance.